Welcome back to Binary Wonder. Today we're going to look at an 8-bit single board Z80 computer. Hey guys, welcome back to Binary Wonder. So today I wanted to show you a 8-bit computer board that I got recently. It is this here, which is built by a company or an individual who's got a website called CPUville, and it's a really fantastic product. I've only had the chance to play with it a little bit, and I can give you a bit of a demo on how this works. But you can see that it's essentially a modern 8-bit machine. This one actually has a Z80 processor running at 1.8 megahertz is the clock on here, and I can go through some of these features here. So I know you've probably seen my original YouTube video, the very first one, where I had CPM running on an Arduino device, an Arduino Due, which had an SD sled and some other software run CPM on it. So check out my very first video on YouTube if you haven't seen it. But this one takes it a bit farther. So where Arduino was actually a modded version of CPM running on that ARM-based Arduino, this is actually a legitimate, brand new 8-bit machine. And what's interesting about this is how simple it is. So what I really enjoy about 8-bit machines is you can understand everything that's going on in this board electrically. It's actually not that hard. In fact, Don at CPUville, who actually created this, has the schematics on his website. So you can actually understand the 8-bit data bus coming out of the Z80 processor, the 16-bit address bus for referencing the memory, and all of the other components here electrically. So I'll sort of give you an overview of the major parts. So we've got the Z80 processor there. This is the 1.8 megahertz clock. There's a ROM chip. This has version 8 of Don at CPUville's custom monitor. There are two 32K chips, memory chips, RAM, and that ROM is 2K, by the way. So what you've got here is, and since the Z80 only has a 16-bit address bus, 2 to the 16th power is only 64 kilobytes. So it can only address 64K worth of memory addresses. So even if you had more than 64K, because of the Z80 only having 16 bits to address memory, even if you had more than 64K, it wouldn't be accessible to the processor unless you did something special and had some other additional logic to sort of page in or somehow rotate the memory. 16 bits or 64K is all you're going to have. And this also has an IDE connection, so you can do a SD to IDE or compact flash to IDE, which I intend to do here. This only has one RS-232 serial connection, and I'll show you what it looks like. And this uses a 5-volt power supply, the same that you'd use on maybe an Arduino. And that's essentially it. There's a power LED, there's a disk drive LED, there's a reset button. These chips up here are for the serial, and then there are some chips associated with the memory, some logic that has to do with the memory, and then there's sort of this expansion edge which you can actually get access to all 8 bits of the data bus and all 16 bits of the address bus. But that's pretty much it. There's a power supply here, a power feed, where you can actually, if your SD to IDE device actually requires power, you can tap into the 5 volts that are needed here. And the Z80 can actually operate at a number of different clock speeds, but this actual crystal is only 1.8 megahertz, so that's what it's going to operate in. So let's see what it looks like actually connected through serial. So here we are. I've got the it's showing the carriage return line feed characters, that's okay. If I'm at the monitor prompt, I don't have CP/M running on here. I need the SD to IDE to have that available, but if I choose dump, it'll show me a 256 block of memory. If I go to 0800, which is the beginning in hex, 0800 or 800 in hex, translates to the 2K memory mark. So if you remember, the ROM takes up 2K, and then the RAM sort of begins at the 2048 memory address, and then higher will be all in RAM. So what I'm telling this is dump out the memory at the beginning of RAM. And what you can see here is 16 by 16 or 256 byte block of memory. And what you see here is you see the hex codes. So on the left, 0800, 810, 820, you're seeing those memory addresses, and then D7, 90, these are 1 byte blocks of memory. So each row is 16 bytes, which makes sense because in hexadecimal there are 16 until it goes to the next one. So you see it's 0800 and then it goes to 0810. Well, that's not just 10 positions because we're in base 16. This is hexadecimal. There are 16 positions. So there are 16 columns of 1 byte hexadecimal items. And if it's an ASCII character, then you'll be able to translate that hexadecimal byte, like 7F, B2. If you have an ASCII table handy, you can convert those to whatever the ASCII characters they are. So anyway, this is just the beginning of my exploration into this CPU Z80 single board computer, and I plan on attaching the SD to IDE and then installing CP/M and actually running some of the same programs you saw on my Arduino based device running CP/M as my original video. So more to come on this, but I'm very excited about this 8-bit machine and can't wait to show you more and explain a little bit about assembly code, and a little bit about the Z80 architecture, and just memory locations and some electrical understanding about what's going on in that board. I think it's a really awesome tool to have, and I'm thankful for Don at CPUville for constructing this for me, and I'm looking forward to spending time working on it. So take care, guys.